Good afternoon, everyone. I'm Bill Sanders, the Dr. William D. and Nancy W. Strecker Dean of the College of Engineering. Welcome to the College of Engineering's webinar series, Faculty Insights, a 20-minute briefing. Thanks for being here today. In this series, faculty from across the College of Engineering share insights into their research, its impact, and provide perspectives for the future. Following each 20-minute presentation, attendees will have an opportunity to direct questions and comments to the speaker. Our speaker today, Professor Erica Fuchs, the Kovtchek-Mora Professor of Engineering and Public Policy and Director of the Critical Technology Initiative, will give a presentation entitled Analytics for Critical Technology Investment and Policy. During this program, she will discuss how Carnegie Mellon's University's Critical Technology Initiative is pioneering advanced analytics to help nations smartly invest in and enact policies to enhance competitiveness in technologies critical to national security, economic competitiveness, and the well-being of all citizens. As director of the Critical Technology Initiative at CMU, Professor Fuchs is bringing together an interdisciplinary expertise across 5 different colleges to pioneer how advanced analytics can ensure we smartly invest in and enact policies to achieve competitiveness in technologies critical to these items that I talked about. As part of this effort, Erica catalyzed and served as the founding director of the National Network for Critical Technology Assessment, which mobilized academic thought leaders from more than 13 Tier 1 research universities across the country to develop a vision for critical technology assessment, including capabilities and demonstration of those capabilities, gaps, and the investment needed to realize that vision. Their year-long work culminated in the report, Securing America's Future, a framework for critical technology assessment. Erica was previously the founding director of Carnegie Mellon's Manufacturing Futures Initiative, an initiative across 6 colleges, which today is an endowed institute. Erica currently serves on the board of trustees of Netcast, the nonprofit that oversees the National Semiconductor Technology Center. She's on MIT Corporation's visiting committee for the Institute for Data Systems and Society, and on the advisory editorial board for research policy. She has testified in congressional hearings both in the House and Senate and had her work covered, among others, by Axios, NPR, Bloomberg, and the New York Times. Erica earned her PhD in engineering systems, her master's in technology policy, and her bachelor's in material science and engineering from MIT, and spent 1999 to 2000 as a fellow in the United Nations Industrial Development Organization in Beijing, China. Before I turn the screen over to Erica, I would like to remind all of you to please use the Q&A feature at the bottom of your screen to submit your questions to Erica regarding her presentation. You can do this at any time while she is speaking. Gina Henry, Associate Director for the Advancement in Engineering, will be moderating the question and answer session with Erica at the conclusion of the presentation. Erica, thank you for being here with us today. Over to you.
Bill, it is an absolute honor to be here today and to be talking about analytics to help us more smartly invest in and enact policies by nations. So I am sorry, give me one moment just to okay. Gina, I just want you to know, and Bill, that I cannot see the chat in this newer format right now. I do have a cell phone if you need to reach me for texts. So it is an honor to be here today. I am going to talk about, as Bill said, our initiative, our critical technology initiative, to help think about how we can more smartly invest in technologies critical for economic competitiveness, security, and societal well-being. So with the globalization of both knowledge and production, so we are not where we were, for example, coming out of World War II, after there were 80 years of the Western world proponenting free trade, where most of knowledge and production was in one location. Today, that is globalized around the world with increasing sources, however, of geopolitical conflict, of natural and man-made disasters, and what some would refer to as technological quote-unquote shocks, whether that be ChatGPT or DeepSeek. I would say others might not think of those as shocks, particularly at Carnegie Mellon. They might have been able to see these evolutions coming. Nations across the world and frankly, industry face new challenges to national security, to their citizens' economic prosperity and their own economic prosperity, and broad-based societal well-being, whether that be health or otherwise. Unfortunately, as we think back to the pandemic and the semiconductor shortage, rather than strategic forward-looking assessments and prioritization of technology investments and policy actions, many countries, and particularly the United States, is repeatedly being caught off guard by the next crisis. This isn't, however, in some ways surprising. There really is little evidence to support whether, when, and how to direct policymakers' resources, nor the institutional capacity to collect and analyze the data needed. So initially, frankly, under a moonshot, funded by the College of Engineering, which spanned the Heinz School of Public Policy and the School of Computer Science, and now through this broader critical technology initiative, which spans 5 colleges, including Tepper, Heinz, Engineering, Computer Science, and Dietrich. Here at Carnegie Mellon, we are bringing together faculty across engineering, computer science, economics, and other social sciences, including security studies, to ask, how can we take the last several decades' explosion in analytic capabilities and really at the intersection of these disciplines in a way truly Carnegie Mellon, build a new field that can be strategic and forward-looking and help fill this gap. So as I mentioned, this goes all the way back to the pandemic. And it was at that time and before the pandemic that the College of Engineering had funded a moonshot to start thinking about how analytics could help us make better decisions in a strategic and forward-looking fashion. And so actually, during the first Trump administration and then ongoing through the Biden administration, I was testifying based on work that we had been producing out of the moonshot that it really was possible to be strategic and forward-looking, to leverage integrated interdisciplinary teams to, in a whole new way, get into real-world problems and having actions that could be taken by government, better, smarter actions coming out of those analytics, to focus on the problems at the intersection of departmental missions, not just defense by itself, not just commerce by itself, not just labor by itself, but really what are the win-wins and trade-offs across those missions? Because technology, whether it be semiconductors or medical devices, those don't have a single mission, they span them. And also that we really needed for governments, for nations, a neutral third party that was not any one of those stakeholders. It wasn't industry stakeholders, and it wasn't government stakeholders from different agencies or political parties, nor was it even individual academic stakeholders. So based on those testimonies, I was tapped to lead what Bill mentioned was a pilot, a 1-year, $4 million pilot national network for critical technology assessment. And the question was, could we demonstrate what the best analytics today across the country could do to help inform, more smartly invest in technologies and also more smartly enact policies for the country's multiple missions. And this was directly connected to the bipartisan mandate that the country begin to have a national technology strategy. So in this this sprint, which it was, we had the goal was not just to fund individual universities to do what they were already doing, but rather to marshal the distributed capabilities in such a way that the whole was a greater than the sum of the parts. So we took, for example, the very best in critical mineral capabilities at MIT and combined it with the very best in industrial organization modeling at Carnegie Mellon, and with the very best in certain labor work going on at Georgia Tech. And how do we bring that together to answer questions none of those scholars could have answered on their own? Now, there was one thing, which is that Carnegie Mellon happened to be, I would argue, to have some of the best analytic capabilities across the country. And so 7 of the 22 faculty were from Carnegie Mellon University in terms of the faculty leaders, even though there were not only 13 institutions and 22 faculty writ large who were leaders in this effort, but also underneath each of those faculty, more than 5 faculty. So, but Carnegie Mellon was very much central to driving this. So you can go to nncta.org and see the final report that came out, which is Securing America's Future. From there, Carnegie Mellon continued with the support of the Alfred P. Sloan Foundation to push forward not just on what the country could do today. And in building the national network, we had engagement from very top industry leaders, CTOs of Microsoft and chief scientists at Intel and CTOs of Lockheed Martin, as well as leaders within government and the agencies, working with us the whole way on what they saw as being needed. But we wanted to go farther at Carnegie Mellon, and this led to our 5-college initiative, and ask not just what we could do today, but what should we do? How should we be able to have strategic forward-looking analytics to support policy? And what we came up with was that we really believed there was a discipline to be built here in the way that Carnegie Mellon has built the School of Machine Learning and has the only Department of Engineering and Public Policy in the country. And that what we wanted to do was establish better timely awareness with modern data and analytics, including natural language processing and crowdsourcing and otherwise, quantify criticality in terms of how large an impact. Was this something we needed to invest in right away or not? What was the scale of the vulnerability? What was the scale of the opportunity? Prioritize then action. What did we need to do to solve that vulnerability or that problem? As well as retroactively figure out if we were right and evaluate the impacts of policy or investment actions. And finally, understand deeply and exploit interdependencies. Often in a global system, if you take one action, it could lead to the opposite of what you intended. And so how do we understand that, whether that be across technologies, and maybe you need the whole stack in order for it to work, or that be across countries and systems, political systems. So the other was that we really put technology at the center of building resilience and of policy. So our work, we realized more maybe than every other university out there, was inside technology decision-making as an action that could change the workforce needs and the workforce readiness, that could change regional capabilities and regional readiness, and could even change who were the potential international allies. So driving and using technology to architect our strategic advantage and nation's strategic advantage is central to the way that we're thinking about these problems. So let me give you some examples. What do we mean by timely awareness? Well, here you can see that during the pandemic, our team was actually able to identify at minimum 10 to 20% more capacity for production of masks and respirators than the White House knew it had by following the classic pandemic playbook. And the reason that is not because the White House wasn't doing the right thing. It did what you're supposed to do. It brought together the big five, Honeywell, 3M, and so forth. And they still thought they had only half the capacity they needed. But a very smart Carnegie Mellon PhD student said, hey, I could actually use natural language processing and text processing to read B2B sites and see these new companies coming online. And they're even stating their capacity. And we had to confirm them, call them up, make sure they actually had a mask coming offline. But this was much more capacity than the country thought they had. And that really changes how you approach policy, because if you have a lot more capacity, you're no longer negotiating with other countries in the same way. Of course, you can't do this in semiconductors, right? We're not going to have here, you're seeing masks and respirator producers showing up, within days and weeks. It takes 5 years or 3 years and over $1 billion investment to get a semiconductor fab. And actually our team looked at that quite differently in terms of how alternative designs could instead enhance supply chain flexibility and strategic advantage during the semiconductor shortage. So in quantifying vulnerabilities, we also, unlike other groups, weren't just looking at a list of quote unquote critical technologies, but we were saying what makes it critical and what do we really need to worry about? So here, at Carnegie Mellon, as part of the national network, joint with MIT and Georgia Tech, but really we were leading this effort. We asked experts, what are the things you're most worried about before any of these things happened? So you're worried about China restricting lithium exports by 15%. You're worried about graphite restrictions by the PRC, or you're worried about cobalt restrictions. And then we said, what of those do we really need to worry about? We modeled all the mines. MIT had the best data on that in the country, and mines coming up online. We modeled as those commodity prices changed and lags for mines coming up online. How did that change battery production costs based on techno-economic battery models we had? And then we put that into an industrial organization model to say what would be the economic impact of each of these different possible restrictions that could happen. And the fact is graphite and nickel, which government was very worried about, those were not in the top 3 of what we needed to worry about. And actually, we were able to tell them that before China restricted graphite. However, the China restricting lithium exports by just 15%, we were able to show that that would have the same economic impact as the 2021 semiconductor shortage did. And that is $24 billion in consumer surplus losses, more than 22,000 laborers' wage months lost. And that's even with assuming that the US lithium mine is up online. So if you add on the far right, the US lithium mine delay on top of that, then it's an even bigger, especially with the uncertainty, economic impact than the semiconductor shortage. Similarly, restrictions of about 14%, which is what people were worried about for a variety of reasons, from the Democratic Republic of Congo for cobalt, would have equally large or next most large economic impacts. But we could go farther with our team because of our underlying modeling capabilities. We could say, what do you have to do? You don't have to have endless numbers of mines. If this is what you're worried about, a 15% restriction, then we can tell you, you only need 100 kilotons of lithium carbonate equivalent more, access more to lithium carbonate equivalent to really ameliorate our vulnerability to a 15% restriction from the People's Republic of China. And just so you know, even if there are let's say another country would fully cut off, and specifically China, because a large amount of our supply of lithium right now comes from that, would come from that. That doesn't actually mean that it doesn't still get to the US through other countries, and we can talk about that in Q&A. Similarly, if you reduced the number of batteries that are battery electric vehicles that are using cobalt, nickel, cobalt, manganese, which is the industry norm right now, to be cobalt free, which is done, for example, by Tesla and some other manufacturers worldwide, that also would reduce these vulnerabilities, and you can see that 80% maybe doesn't get you as far as you would want to get, that actually you might need to move towards 100% of battery electric vehicles being cobalt free, because there are some battery applications that do require the high energy density of nickel, cobalt, manganese. So we also were able to say, for policy like the manufacturing incentives program, where there were going to be problems, where was there going to be a choke point from a workforce perspective before the workforce choke points started to happen. So about 65% skill similarity with a new job is generally in the literature suggested necessary to make that job transition. So you can see here that in Columbus, Ohio, where a manufacturing incentives program was putting Intel was supposed to put a facility, you would have to be able to train people who had only 50% of the skills to meet, for example, the 3,000 semiconductor processing technicians that Intel needed for that site. In Sherman Denniston, Texas, however, even if you could train people who had 50% of the skills, which we don't know you can, maybe we'll get some smart tutors in there from Carnegie Mellon. But even then, you still don't have the 4,500 semiconductor processing technicians that TI believed it needed for that site. And I will say that in our data, the most workforce ready location was Arizona. And we are now in contact with the former chairman of TSMC because despite that being the most ready in our data, there, as is publicly known in the news, also had problems where they ended up bringing in workers from Taiwan in order to get that facility up and running. So finally, in thinking about understanding and avoiding unintended consequences, you can see here that during the pandemic, when the U.S. used the Defense Production Act and under Operations Warp Speed and in the Department of Homeland Security, what are called priority rated contracts, which said, you must produce ventilators for the United States or whatever the medical need might have been before you can produce for anyone else. It's used widely also by the Department of Defense, that actually the U.S. loses during that period, as expected, global market share, but it loses global market share in the long term as well, that trend continues, and that our allies here, in this case, the EU, increase their reliance on other nations, primarily China and Australia in this context. That doesn't mean there's a simple answer here, but it's something we need to understand when we make an action, that there could be long-term consequences. And then how do we balance that out? We want ventilators for our citizens, but also we want to reduce possible long-term losses for our companies in terms of global market share. So last but not least, we are thinking about knowledge networks and knowledge capabilities globally no differently than we are thinking about, or very similarly to, production networks. So here you can see that this is from Philippe Aghion at INSEAD. It was part of our national network. And he looked at the China shock previously and how the requirements that you were no longer allowed to co-author between the US and China led to fewer publications and lower output by both countries. So it hurt both countries. And what we are interested in doing is getting into the details of these collaborations, the lack of collaborations, and more particularly, how we could think about designing strategic advantage, designing where we collaborate and don't collaborate more explicitly as we go forward and think about knowledge networks as well. So I want to end by saying in the 1950s and 60s, Andrew Marshall basically built the field of net assessment and modern defense strategy. We're interested with the explosion of analytic techniques in building a field of analytic intelligence for modern national technology strategy across missions, not just for defense, but thinking about the well-being of all citizens. And he had at the time said that he'd rather have decent answers to the right question than great answers to irrelevant questions. And with today's advanced analytics at Carnegie Mellon, we believe we can have both. And should I stop sharing now?
Erica, thank you so much.
And I
Yes,
can now see chat. Something has changed. Yes.
good. Thank you so much, Erica, for that great presentation. We're going to move into the Q&A portion. And I just want to remind everybody that you should see a little Q&A box at the bottom of your Zoom screen. And so if you have a question for Erica, please put that in now. I should do a reintroduction in case some of you joined us a bit later. My name is Gina Henry, and I am the Associate Dean for Advancement in the College of Engineering, working closely with Erica and many of our other faculty. And so, Erica, again, thank you so much for doing this presentation. So while the questions are coming in, we've already had a couple that came in while you were presenting, and a couple of the questions were related. So I'm gonna do my best to combine them. How might this initiative be used by the current government or other entities to answer questions around energy resources or environmental issues?
Great. So one of the things that both in leading more broadly and in building this field, I believe is particularly important. And I'm going to speak for myself, not for all the faculty, is that as we have an elected government in the United States, that it is legislators' responsibility to decide their values and how they weigh them, and our responsibility to get them better analytic information to inform their decisions. And that's for any nation. We see ourselves as building a field for this capability for any country. And so I think the answer on that is we definitely have data. There is a simulator, for example, up online that looks at the Inflation Reduction Act and its subsidies for battery electric vehicles. It shows that battery electric vehicles are incentivized by the Inflation Reduction Act, and it also shows that due to some loopholes and also the foreign entity of concern restriction not having as much as a financial consequence, that it doesn't solve the first part of the supply chain, sort of the mining and processing of cathodes and anodes, possible challenges. And so I would argue that if someone from a climate, so first off, you can go online and play with the simulator with subsidies in the United States and other countries. But second off, I would say that people who have very different views on climate could use that simulator to make different arguments in government. And I think that our job is to provide the information.
Great, Erica, thank you. I should also say that you're getting a lot of accolades in the Q&A. A lot of people are commending you on a great and informative presentation. The next question is about the intersection with your work and the library. So someone who is an academic librarian asked the question saying that they appreciated the bibliometric co-author study, and they wonder if CMU Libraries was involved with the work and if you see any barriers in the information ecosystem to your research.
Yes. So I think, first off, we have probably the top person in maybe the nation or world, Lee Brandstetter, who does bibliometric and patenting studies. We also were leveraging people from across the country and world in the national network. We did not involve the libraries, in part because while there are, for example, the NSF science and engineering indicators are publicly available, the extent of careful work necessary to be able to dig in depth into these and actually even have interactive models it is greater than and really make sure you're measuring the right thing is greater than what would be done with the library system or with even using NSF's science and engineering system. For example, Lee Brandstetter uses natural language processing to identify whether or not a patent has AI in it rather than keywords. And that has proven to have better measurement of AI than, and indeed that better suggests an increase in productivity due to AI and in jobs actually than others. I would say more broadly that the relevant data and people pioneering that NLP is an incredibly important sensing and timely sensing technique, as well as deep engagement with industry. So often industry will work with us because of their desire to have a neutral third party. And you know, we have some of these examples are using shop floor level data and design information from 65% by revenue of manufacturing facilities around the world. So that type of depth of data is often not comfortably given to government, but given to academia also because we might have insights into operations or design that in addition to then being able to be a conduit to provide neutral information to policy.
Great, thank you. Next question. Your work often explores the intersection of emerging technologies and national competitiveness. What do you see as the most urgent policy shift needed to ensure the U.S. remains a global leader in advanced manufacturing?
I would say that, and actually this speaks a little bit to one person who has a drone technology question. I would argue that we underestimate both the potential for redesign. If your interest is US manufacturing, we underestimate the potential for redesign. And I think people overestimate how much workforce costs or issues are an issue. So I would argue two things. One is that you know, we have analytic data from global manufacturing and design facilities that would suggest there are a wide array of technologies and designs, like in optoelectronic semiconductors for transceivers and sensing, where the US with alternative product designs, like using monolithic integration of multiple functions on a chip, can be actually cheaper than discrete alternatives in other nations. If that is, you know, if we're thinking about the US here, and actually that is US, Europe, and Japan. I think that so I really think there's actually a very nice analog we're working on in drones to the person who asked the drone question. I think that we really need to ask about training our workforce because we have lost such a dramatic capacity. And we are working here on questions of augmented reality and smart tutors, as well as, you know, once you identify these gaps, like with the manufacturing incentives program, we need to act on those with that data in hand. Yeah, so I would say my greatest concern is our workforce, because these are actually high school educated jobs on the operator and sometimes even the technician front that have agency in the innovation process and getting product successfully out the door because they're more advanced products. So there's real work to be done there.
Thank you. Practical question. Someone asked that you mentioned the 2023 report. Is there a new version of that report out or coming out soon?
Thanks, Frank. We So that was a 1-year pilot that was paid for by the US government, specifically the National Science Foundation. I was 3 months ago asked to to speak to the National Science Board under the new chair, Dario Gil. I would say that Carnegie Mellon is at this moment producing policy briefs based on our work that we are pioneering. And there is a nascent question that I would be happy to discuss offline about whether this might go forward. But up until this point in time, there was a pilot, and actually Europe, Japan, and Korea, I have all been told, are trying to copy and emulate what we did, but our country has not moved yet. So I'm happy to take that offline.
Great, thanks, Erica. We had, and if you can see the question, you can probably see some of the detail here. But on the respirator market share, is it that the U.S. production actually went down, or did capacity get generated in ROW that took a share of an increased market? And the person asking this question pointed out about percentages versus actual numbers.
Yeah, we could send, the paper is public online, Ned, and we can send that to you. But I think the short answer is that while there is a spike during the pandemic in total production, it is both the volume and the share that have gone down.
Good. Thank you.
I think it's heterogeneous. If you look for it, Afonso Amaral, doctoral student, Carnegie Mellon. You probably find it. So, it's on our website. Actually, it's on the Critical Technology Initiative website.
Great, Erica. That was actually a softball intro to my next question, which is, can you talk a little bit about how students are involved in this work, either graduate students, undergraduate students? How have they been involved?
Absolutely. So students have been involved throughout. So first off, we have, especially since pushing forward with the Critical Technology Initiative, we have both undergrads, masters, and PhD students engaged in research in one way or another from countries around the world. We also have in the national network, the activities that happened at Carnegie Mellon. Frankly, I feel so proud about this, but 4 doctoral students here were part of making some of the figures that synthesized across the work. They attended those meetings, met both the leaders, and even a double major undergrad did some support work on this. So really amazing involvement. And they are, if you look in really fine print in the national network, every single one of them is acknowledged and thanked. So
I love it. I love seeing our students involved in this way. So the next question is about modeling. How do you approach modeling the complex feedback loops between technological innovation, policy, and market evolution in your research? And can you share an example of where these dynamics have produced really surprising insights?
Yeah. I really like I'll give 2 examples, but one is I really like the example of in our work on critical minerals, which I showed you all today, that it turns out our further work shows that during the shock, firms, we can differentiate between firms' private profits and their public sort of consumer surplus losses. And while it doesn't help the firm either in the long term, having the supply they need and maintaining customers, their profits can in certain cases rise during those shortages, which helps explain also, it's a piece of the larger puzzle. So I think that's, maybe I can leave it there. I can also talk about the technology interdependencies. I'll say one more thing there. Which is we're working right now on a project about choke points in the expansion of AI. And it is just so neat to have the depth of analytic capability that we have built here at Carnegie Mellon. We are able to look at that from a training perspective in terms of, we actually had a conversation about, do we need ducks who can, boundary span two fields, AI and this, or do we just need, one of each of those professors to work together? And that the answer was different in different AI for science disciplines, but also we could look at energy choke points, at compute choke points in very, very quantitative ways. So the fact that all of these, something like the advance in AI depends on the data you have access to. It depends on the compute you have access to. It depends on the and the types of chips you have access to. And then, what happens if you can only use data in this country and chips in that country, and the algorithms, it all depends on that. And then it depends on the energy sources that you have. This is also interdependent. We just shine in those types of problems.
Fantastic. Thank you. Next question relates to something that's important to all of us, I think, and that is the importance of translating our work to people who may not be necessarily technical, have a technical background. And so one of our attendees has asked what are you doing to put your results into stories that can be understood by non-technical folks, whether that's people in government or elsewhere?
Yeah. So I'm going to say two things about that. One is that the government relations folks at Carnegie Mellon have been absolutely incredible about supporting in terms of when I've testified. We have now hired in actually Carnegie Mellon and EPP and the Scott Institute and the Critical Technology Initiative, someone whose sole position is to create policy briefs. And so funnily enough, she'll also often be like, well, this is very nice for a technical audience, but now we're going to rewrite this in a way. And so I really think the Carnegie Mellon support infrastructure has been magical about that. We also, during the national network, hired not only a technical editor who had previously worked at the National Academies and helped communicate to broader audiences, but also we had a policy communications former head of government relations who is now retired, who's known for actually having created sort of some incredible institutional change in government. Also, as basically we had an academic reviewer, industry reviewer, a policy reviewer, and a technical editor, and we were all sitting there together, like arguing, no, you can't say that, but no one's going to understand that. So that was wonderful. I see the next question. I'll let you read it, Gina, but I can answer that. Yeah.
Sure. Thank you for that previous answer. So I'll just read this one directly. The speed of change surrounding both the offense and defense surrounding drones for war seems to challenge the very strategy development you outlined here. Do you see your methodology as helping focus the scientific and manufacturing capability on the paradigm shifts that are necessary to shift our approaches to keep pace with the speed of advancement, both offensively and defensively, in war application of drones?
Thank you very much for this question. Let me, I'm going to first say that I'm a humanist, and then I'm going to, and then I will say that my executive director was trained the forces in the Ukraine, and is an Army colonel, lieutenant colonel, former retired. He told me that, in some ways, all people who have also gone to war are humanists. So, but let me say this. We are, first off, we have a paper currently under review, but that has already been shared, which looks at actual supply chain issues in drones for like the Ukrainian UAV. I can tell you that they're not as bad as it might look at first blush. and that there's a lot of very rapid immediate redesign and rapid surge capacity that could be implemented in that space. And we actually are doing research on that. And also I will be down at DARPA. I'm driving down immediately after this meeting. These are areas where we are able to be of help, and both in understanding, just like the mask example I gave, where we could have rapid surge capacity and where we would need to change designs or otherwise to have that capacity, as well as redesigning to ensure access. So that is something I'm happy to talk about offline.
Thank you.
And
Looks like we have.
I should also add that we have activities in shipbuilding, in artillery. I'm happy to talk about that.
Thank you. Looks like we have one final question before we wrap up. So you've emphasized the importance of aligning technological advancement with societal goals. What are some of the most promising policy methods for achieving these?
Yep. My simple answer is that I would argue they are often more aligned than people think. And I think that that is a huge advantage of this type of work. And I'm going to give 3 examples. One is in our early work on optoelectronic sensors and transceivers. One is that moving manufacturing overseas actually slowed down technological advancement worldwide. So it wasn't better necessarily for the other country either, because the older discrete technologies were more economically viable to produce overseas, and it made it that there was a bigger economic hurdle in order to introduce more novel technologies that would advance, could be compute capabilities worldwide or otherwise. Those also, those same optoelectronic sensors and transceivers, could be, and I'll use a military example here, but they not only have applicability in sensors for society and in computers, but they could be put it in a contact lens of a soldier to help them stay safe if a missile were coming in and give them early alert. Or maybe they could be used for more other societal benefit. Example. Let me give 2 others. I think that, and they have better jobs, like with agency than the older technology, for the individuals who are high school educated being part of the innovation process, rather than just sort of a tool on the line. I think that, if Europe were to implement a carbon border tax, U.S. steelworkers were to actually be more competitive. And I think it's these types of understanding of win-wins across possibly where there are different values or missions that are particularly important to help us move forward, because I think all citizens around the world want jobs. They want a reasonably healthy life, and I think helping us, all nations, make decisions that help them get there to achieve their objectives under the right, is important.
Erica, thank you so much for spending so much time with us today and being willing to answer all these complex questions. We really appreciate it. I want to say a big thank you to everyone who joined us online to participate in this webinar. And thank everyone for making the time to learn a little bit about Erica and her work happening here at CMU. We are going to be doing more Faculty Insights series. We will pick this series back up with the beginning of the fall semester. So keep an eye on your email and look out for a whole new slate of speakers beginning in the fall of the year. Thank you again to Erica, and thank you again to everyone who joined us.
Thank you, Gina and Bill.
Bye, everyone.